Hey Ms. Botticelli, hey class. Today I'll be talking about how spectroscopy could determine small amounts of drugs in the human body. So what is spectroscopy? Here's some history on it. Sir Isaac Newton began experimenting on optical devices. During these experiments, he observed a spectrum formed by white light passing through a prism. Later in the early 1800s, Joseph von Fraunhofer expanded on the discovery of the spectrum from Sir Isaac Newton's. Fraunhofer first observed spectral lines and was first to use the standard of comparing spectra, which is the basis of spectroscopy. Spectroscopy is predominantly used in astronomy, chemistry, and physics. It uses dispersion of energy in the form of different colored light. Each color has a different wavelength and therefore different energies. Energies of a given sample can depict its physical properties such as temperature, mass, luminosity, and composition. Spectroscopy utilizes the electromagnetic spectrum. Light particles are called photons. We use the electromagnetic spectrum to classify light waves based on their wavelengths and energies. Photons of longer wavelengths have lower energy, shorter wavelengths have higher energy. Aside from the visible spectrum, electromagnetic waves are invisible to the naked eye. There are two types of spectra. There is continuous and there is discrete. In a continuous spectrum, some objects have different wavelengths and have different ranges that can emit a wide spectrum of light that seems continuous. In a continuous spectrum, light that is emitted may be absorbed, and therefore there are black lines where it can be absorbed. In a discrete spectra, it shows what wavelengths are being emitted from a given sample of an atom. This topic can be found in the McGraw-Hill-Ryerson Chemistry 11 textbook. It can be found on Chapter 6 on proportions in chemical compounds. In Unit 6, we learned about the empirical and molecular formulas that can help us figure out elements and atom numbers of chemical proportions. Spectroscopy can determine drugs in a given sample in two ways: fluorescence spectroscopy and mass spectroscopy. What is fluorescence spectroscopy? Fluorescence spectroscopy studies the emission and absorption spectra in a sample using a fluorescent compound called fluorochromes. Fluorochromes are tagged or attached onto molecules and drugs that we are interested in finding. Fluorescence spectroscopy analyzes the emission and absorption that is emitted by the molecule. The absorption spectra is measured by the amount of energy that interacts with the electron. The photon with the sufficient energy excites the electron to move from its ground state to an excited state. The electron cannot stay in the excited state for a long period of time. The emission spectra is measured when the electron goes from the excited state back to its ground state. The data output is given in the form of the emission and absorption spectra graph. The absorption-emission spectra is a spectral fingerprint of the molecule. The fluorescence spectroscopy provides a rapid response to the identification of a particular drug or disease in which we are interested. Using a process called immunoassays, we can use fluorescence to detect drugs in the blood and urine samples. In the summary of fluorescence spectroscopy, through the use of fluorochromes, uses the absorption-emission spectra as a unique spectral fingerprint of molecules and for this study to determine what is contained in the sample. Mass spectroscopy can determine how many molecules or concentration there are in a sample using a mass-to-charge ratio. A mass spectrometer is used for this technique. A mass spectrometer is used to identify molecules by breaking them down into ions and then sorting them using the mass-to-charge ratio. As the sample enters the spectrometer, the sample gets bombarded by electrons that form cations or positively charged ions. These ions are then sorted and propelled into a magnetic field. Going through the magnetic field, the ions are then deflected depending on their mass and charge. The higher the mass and charge, the less it deflects. The lower the mass and charge, the more it deflects. After the detection plate, there will be a data analysis that will show you in a mass to charge ratio and a total ion count of how many positive ions there are. So for example, I have here for Tylenol. For example, if I put Tylenol into the mass spectrometer and Advil in the mass spectrometer, I will have two different completely charts. Using the mass to charge ratios and the stick diagram, it can determine what drug or drugs that are in the sample by the grouping of ions. The data output shows the concentration of ions in the sample. As stated earlier, this is dependent on the deflection patterns of the ions as they went through the magnetic field. The lines on the stick diagram depict the concentration of ions related to their mass to charge ratio. What Canada has done to detect a small amount of drugs in the human body is to introduce a program called the Canadian Anti-Doping Program, which educates on drugs that are prohibited in Olympic events and educate how drug tests work. The risks and benefits to society and the environment. As a society, it does help improve skills such as speed and muscle bulking, but you can grow dependent on the drugs, and a risk of taking the enhancement drugs can be long-term because no matter how effective it could be to help your speed and muscle bulk, it can affect your mentality and physical change as you grow more dependent onto the drugs. An environmental risk is that drugs are disposed of in toilets or down sinks and get into our water systems and into the ocean. Sometimes in fluorescence spectroscopy, there is a use of UV rays as excitation wavelength. This possesses a problem because ultraviolet light can contain enough energy to ionize atoms. This means there may be enough energy to eject an electron. That ejected electron can have a high enough velocity speed to damage DNA in the cell. So how does my topic relate with spectroscopy? Well, with my topic, there are different ways with fluorescence and mass spectroscopy that use different spectras and different wavelengths to determine the substance in a sample. Well, that is the end of my video, and thank you, Miss. I feel like I did enjoy a lot, so I hope you understand what I was talking about, so thank you. I'm sorry.
Spectroscopy is used in three different. I'll just put your hand here so you know. There are two types of spectra. There is continuous and there is discrete. Spectroscopy uses.
What is fluorescent?
This topic relates to the electromagnetic spectrum classified. Hello, Ms. Bartelli and class. Today I'll be talking about how spectroscopy can be used in. Spectroscopy predominantly is absorption and emission spectra. There are two ways. A mass spectroscopy is absorption and emission. Spectroscopy is predominantly used in astronomy, chemistry, and physics. It is used in an environmental risk is that drugs are disposed of in toilets or downstreams and get into our water systems and into the ocean. A mass spectrometer is used to identify molecules by breaking identified.
Okay. 1, 2. As the sample enters enters the spectrometer, the sample gets bombarded by electrons that form cations or positively charged.